Hello, statistical scholars. Today I'm going to be focusing on reviewing for our first exam, and I will be covering number 13, which was a requested item for our review session. So I'm going to start by reading the problem and then giving my answers. There's not much writing or calculating for this one, so it's mostly explanation, so I will be writing and typing nothing. Should be fun. So in 2010, the General Societal Survey asked the question, after the average workday, how many hours do you relax or pursue activities you enjoy? And a random sample of 1,155 Americans, a 95% confidence interval for the mean number of hours spent relaxing or pursuing activities they enjoy was 1.38, comma, 1.92. So, our first question is, what does this confidence interval mean in the context of the data? So I'm looking for a couple things here. I want you to mention what these numbers mean, what their units are, and what the confidence interval says about them. So I would say that we are 95% confident that America spend on average between 1.38 and 1.92 hours per day relaxing or enjoying pursuing not enjoying activities they enjoy. Well, I guess that means they enjoy them. Suppose we set another set of researchers reported a confidence interval with a larger margin of error based on the sample of 1,155 Americans. How does the confidence level compare to the confidence level of the interval stated above? So, I actually am going to write something for this one. So, hopefully you remember margin of error is your z star, which comes from your confidence level, times your standard deviation or standard error. So this is either z star or it's the standard deviation, which is the sample standard deviation divided by the square root of the sample size. So as you look at this, they tell you that the sample size has stayed the same. It's 1,155 memory. I hope that's right. So this hasn't changed. However, somehow this got larger, our interval got wider. So a couple things either changed. As you look at this, their standard deviation changed. That's highly suspicious, so probably not. So I would suspect that their confidence level had to have been the thing that got larger, which would be the only thing that would cause your z to get larger. So if you remember, z star is your cutoff for your confidence level. So this is negative z star, and this is z star. And then inside here, we have, that worked well, we have our level of confidence, which, you know, they did a 95%er. I meant to go for black with that one. Which if I wanted to get more confident or less confident, my z's would increase or decrease. So if I wanted to be more confident, then I'd want more area in here, and then my z values would get larger. So I would say that they are more confident. Anyway, back to the question. Suppose next year a new survey asking the same question is conducted, and the sample at this time, the sample size is 2,500. Assuming that the population characteristic with respect to how much time, so characteristics of a population would be like standard deviation and mean, with respect to how much time people spend after their work have not changed much within a year, how much will the margin of error in the 95% confidence interval constructed based on this data for the new survey compare to the margin of error in the interval stated above? So I'm going to go back to my notepad. As we just saw, margin of error, z, and we're doing 95% again, so this is staying the same. Same, I know your name. Standard deviation, and then sample size. So as you look at this, this is assumed to stay the same because this is a population characteristic. The only thing they've changed is they've increased the sample size. So if you increase the thing you're dividing by, you're actually dividing things into larger groups, which means you're getting smaller. So we should expect that the new margin of error will be smaller. So if you ever don't believe this, remember dividing is the same as doing fractions, or pick something you know. So like, you know that 3 is bigger than 2, right? So if you take 6 and divide it by 3, you get 2. This is a terrible example because all my numbers are the same. Let's pick something else. So if you take 6, if you take like 12 and divide it by 2, you get 6, right? However, if you take 12 and divide it by something larger like 3, you get 4. So dividing by something larger gives you something smaller. Ta-da! All right. So you should expect your margin of error to be smaller. And that will end this video. So peace out, homies.